And one more example, sine 330. If you look at this, 330 should lie in the fourth quadrant. When you go around this, you go past 270 and you stop before 360. So when this is 330, the basic angle must be 30. Now we know sine 330, it comes in the fourth quadrant, which actually belongs to cos. Add sugar to coffee, and we know answer of this question would be negative. The basic angle is 30. I'm writing sine 30, but sine 30 is positive. To make them same, I have to put this negative sign here. For sine 420, we already know that 420 goes past 360, so it is actually 60. The basic angle is 60. If I sketch for this is 1 times 360 and 60 more to make 420. 420, 360, the difference is 60. So the basic angle is 60, but in this case for 420 and 60, both lie in the first quadrant. It is already positive, so just sine 60. This is how you express the trigonometric ratios with 30, 45, 60, and you give their exact values. Let us have a look at this tan of negative 120. Let me clear the screen. Tan of negative 120. Negative 120 would mean they move in clockwise direction, and for clockwise direction this keeps moving. It crosses 90 degree and it stops before 180. So if this is 180, this is 120 in the negative direction clockwise, so minus 120. The basic angle is still 60. And add sugar to coffee. This lies in the third quadrant of tan, so tan of negative 120 is already positive and the basic angle is 60, so you just write tan of 60. Tan of negative 120 and tan of 60 give the exact same value and both positive. Look at this tan. The demand of question is to write them as the ratios of 30, 45 or 60. So I'm converting them all into basic angles or acute angles. Let's try one more, you'll get it. So look at tan 210 m part. So for tan 2m 210, now this is already positive, so anti-clockwise this keeps moving, goes past 90, goes past 180 and stops before 270. So this should be 210. We know this is 0, 90, 180, 270, and we always need the angle with the x-axis. So from 180 to 210, this is 30 degrees. Now tan 210 is add sugar to coffee. It lies in the third quadrant. It is already positive, and we know tan 30 is also positive, so no need to add any plus minus sign. Add sugar to coffee. You always check with this, add sugar to coffee. For tan, second and third is negative. For sine, third and fourth is negative. For cos, second and third is negative. Where we write s, there sine is positive. Where we write tan is positive. Where we write cos, c, that is positive. And in the first quadrant, all three are positive. And remaining two are negative in the second quadrant. Sine is positive, remaining two are negative. Tan is positive, remaining two are negative. Look at this, tan of negative 225. If I go for this with the same concept, using the same grid, see, negative 225 means we have to move clockwise. So from 0, and 225 is more than 180, so it crosses this line somewhere here. Now if this is 225, this is 180. To find the difference, we see this is 45 degrees, right? Now before we answer, tan negative 225 actually lands in second quadrant, and there it is positive or negative. Add sugar to coffee. So in second quadrant, is tan positive or negative? Negative, right? So tan negative 225 should give us a negative answer, but when we write it as a basic angle tan 45, that is A, add sugar to coffee, add is all positive, all are positive, but to convert it into negative we are bound to put a negative sign here. One more, tan 135. Tan of 135 would mean this stops here. If this is 135, this angle is 45. So tan again lands in second quadrant. We know if we will punch this number in the calculator, we'll get a negative answer. And if we will punch tan 45, we'll get a positive answer. So they should have the exact same values. We put a negative sign here. Getting it? Let's try cos 300, G part. So for cos of 300, we move anti-clockwise and we stop here past 270. If this is 300, this is 360, the basic angle should be 60. Before we answer, we know that add sugar to coffee. In the fourth quadrant, cos is positive, so cos 300 will be positive, so no need to change, it is exactly equal to cos of 60. Let me write it once for all of these so you can have a better comparison. So if I say we have basic angle of 30 in all four quadrants, so if you had these angles, like the first one is 30, the second one is 150, so cos of 30, or you have cos of 150, or you have cos of, the third one is 210, and the fourth one is, let me open this again, it's getting stuck. So if we have cos of 30, cos of 150, cos of 210 and cos of 330, all these have basic angle as 30. So let us talk about the first one. This right here is 30 and the angle is already 30, so cos 30 is supposed to be cos 30. For 150, if we talk about the second number 150, this should land here. This is 150, the basic angle is still 30. We know that cos of 150 add sugar to coffee, cos in the second quadrant would be negative. So I'm writing cos of 30 with a negative sign. Because cos 30 itself is positive, this negative turns it into a negative value. For the third 210 comes here, and 180 and 210, the difference is 30. This is cos of 30, but we know 210 in third quadrant add sugar to coffee. In third quadrant cos is negative, so we put a negative sign here. For the last one 330, it comes in the fourth quadrant, and we know in the fourth quadrant cos is positive, so no need to change. This is cos of 30. Is it clear? No issues. Let's do it one more with sine. Let's try tan. Let's say we have tan of 30, tan of 150, tan of 210 and tan of 330. Before we solve, we'll just put a positive or negative sign. So just tell me, is tan of 30 positive or negative? tan 30, positive or negative? Where would 30 land? In which quadrant? Let's try it. What would go wrong? Tan 30 in first, second, third, fourth. Which quadrant 30 degree would lie? In the first quadrant. And will it be positive or negative? That's right, positive. Tan of 150, positive or negative? Sorry, that would be negative because it lies in the second quadrant and there only sign is positive. Tan of 210, where does it lie? First, second, third, fourth. In the third, right. It will be positive because it lies in third, and in third tan is positive. Tan of 330, where does it lie? Tan of 330. First, second, third, fourth. That would be negative. So we already know where it lies and what the answer would be, positive, negative. Now we have to convert it into basic angle. And we know that 30 lies in the first quadrant and basic angle is already 30. So I'm just writing it in form of acute angle. Later on we'll decide what we have to put, positive or negative. This is also tan 30. This is also tan 30. And last one is also tan 30. Now we already knew that tan 30 was positive, so no need to change. This is still positive. No need to write anything. So we can also remove this positive sign. Now tan 150 actually is negative, but tan 30 is positive. And the examiner says that write the exact same value. So I am bound to put this negative sign here. Now tan of 150, we can say tan of 150 is actually equal to negative tan of 30. These two are equal. For tan of 210, we need to put a negative sign here. For tan of 330, we need to put a negative sign here. Sorry, for tan of 210, we don't need to put any sign because tan of 210 is positive and tan of 30 is also positive. Quickly with different values for sign. Let's try for sine of 20. So keeping the basic angle same, sine of 160, sine of 200 and sine of 340. Now we already know that the basic angle is 20. So it would be sine of 20, sine of 20, sine of 20 and sine of 20 because basic angle is same all the way. So first one, the question part. The question part, this is the question part, this is the answer part. Question part, is it positive? Sine of 20, is it positive? Sine of 20, it lies in the first quadrant, it is positive, so we don't need to put any sign. Sine of 160, it lies in the second quadrant, and in second quadrant sine is positive, so it is already positive, we don't need to put any sign. For the third case, yes. Yes. We can do that, but we'll need to adjust it with signs. Look at this. If I write sine of minus 20, why so? Sine of 160 has a basic angle of 20, agreed? This is 160 and the basic angle is 20. One thing, sine of negative 20, if we move in clockwise direction, this is negative 20, so both the basic angles are same, we agreed to this. Now sine of 160 lies in second quadrant, which is positive, but sine of negative 20 lies in fourth quadrant. There C is written, that is negative, so I need to put a negative sign here. So when I multiply this negative sign inside the bracket, the overall value becomes positive. Getting it? Third one, sine of 200 lies in the third quadrant. We already know that in third quadrant sine is negative, so we need to put a negative sign here. So this value will be negative. If you punch sine 200 in calculator, the answer would be negative. If you punch negative sine 220, answer would be exactly same with the same sign and same magnitude. For the fourth one, sine 340, it lies in the fourth quadrant. The basic angle is 20. Because it lies in the fourth quadrant, we know that sine 340 is negative, so we need to put a negative sign here. Now let's just try with random values other than 30, 45 and 60. Let me say this is 110. What will be the basic angle? If it is 110, what would be the basic angle? That is 70. Okay, if we started with 110, so sine of 110, cos of 110 and tan of 110. The question is to write exact same values but with acute angles. So we know it is 70. For sine 110, I would write sine 70. For cos, I would write cos 70. For tan, I'll write tan of 70. Now just tell me, for the first case, for case A, do I need to put a positive negative sign? No. Cos of 110. Yes. Tan of 110. Okay, just tell me, is tan 110 positive or negative? Negative. And tan 70? And tan 70 is? So they're different, right? Tan 110, when you put it in calculator, you get a negative answer. But when you plug in tan 70, you get a positive answer. So you need to put a negative sign here. One more, so that they have the exact same value. Yes. Yes. Anyway, that's true. The reversibility is true. Yes. The demand of question is that write the acute number so they have the same value. Now tell me any angle more than 90. We just did with 110, so any other. Okay, so if we do for 120, this is 120 and I'm writing for all three. Sine of 120, cos of 120 and tan of 120. My second question, what is the basic angle? What is the basic angle? Alpha. If this is 120, the remaining would be 180 minus 120 is 60. So basic angle is 60. So sine of 60, cos of 60, tan of 60. We know one thing. Sine 120, sine 60, the magnitude is same, but we need to check if the signs are same. For cos 120, cos 60, magnitude is same. For tan 120, tan 60, magnitude is same. So first one, is sine 120 positive or negative? Add sugar to coffee. Yes, it is positive. And sine 60 also positive. So we don't need to put anything. They are exactly equal. I can say that sine 120 is equal to sine 60. Okay, cos 120 positive or negative? It's negative. And cos 60 alone is positive. So to make them equal, I can say cos of 120 is equal to negative cos of 60, because I cannot make any change in the question. So I have to adjust this negative positive sign with my answer. So tan of 120 was the question, we cannot make any changes. Tan of 120 is positive or negative? Negative. So I need to put a negative sign here, because we know that sine cos tan of acute angles are always positive because of this A. A means all positive. Sine cos tan, all positive. Clear? Or one more? Okay, now any angle in the third quadrant. Any angle in the third quadrant. When you get a choice, that actually makes you confident that you choose anything. You just have to follow the process and your answer will be right. So just choose any number in the third quadrant. Okay, I'll make the choice. This is suppose 210. What would be this basic angle? (210) and 180. What is the difference? It is 30 degrees. So I'm writing sine of 30, cos of 30 and tan of 30. So sine 210, is it positive or negative? 210 comes in the third quadrant. Add sugar to coffee. That's negative. So may I put this negative sign here? Cos 210, positive or negative? Negative, right. Tan of 210, positive or negative? Positive. So no change. Is it clear? Trigonometry needs practice. Now we are moving on to identities portion. Trigonometric identities. There are few you have to memorize. For instance, sine square theta plus cos square theta is equal to 1. First. Second is tan theta equals sine theta divided by cos theta. So we can use these identities to prove that whatever question we have, that left hand side is equal to right hand side or some other requirements of the question. Just to understand these first two, we'll take a basic example of the triangle. Consider this triangle and labeled as W, X and Y, and let me call this angle as theta. So if I write sine theta, and this is right angled triangle, so sine theta is perpendicular over hypotenuse, cos theta is base over hypotenuse, and tan theta is perpendicular over base. So for the first identity, it was sine square theta plus cos square theta is equals to 1. You just have to memorize this. We are doing this proof for satisfaction. So sine square theta plus cos square theta equals 1. We know what sine theta is. So square of this would be x square over w square cos square theta. Cos square is this, so this is y square over w square equals 1. So you take the LCM, that is w square, this is x square plus y square is equals to 1. Now if you multiply this on the other side, that is x square plus y square is equals to w square. What do we get? This is w squared, that is exactly the Pythagoras theorem. So hypotenuse square is equals to base square plus perpendicular square. So left hand side equal to right hand side, proved. This was something you did in grade 6. Hypotenuse is w square, base square plus perpendicular square. So yes, left hand side is equals to right hand side. You just have to memorize this. Sin square theta plus cos square theta is equals to 1. The other thing was tan theta is equals to sin theta divided by cos theta. So I'm just copying the values. Tan theta is x over y, sin theta is x by w, and cos theta is y by w. So when you solve for it, we cancel out this w, and left hand side is equal to right hand side. Now we look at this. If it tells you that simplify the following expressions. Now sin square theta plus cos square theta, that was 1. So it is true for all these. Sin square theta plus cos square theta is equals to 1. So even if you get sin square of 3x plus cos square of 3x, two things are important, that is again 1. Angle must be same and both of them must be squared and added. So we have sin square 3 theta plus cos square 3 theta. This is again equal to 1. Second, if I use the same identity, that is sin square theta plus cos square theta is equals to 1. So for sin square theta, if I make subject sin square theta, this would be 1 minus cos square theta. So we can replace this. So if I take 5 as common, this is 1 minus sin square theta. So in order to get this 1 minus sin square, I can make cos square the subject. If I take this sin square on the other side, this is cos square theta is equals to 1 minus sin square theta. So we can replace these two. So this is 5 cos square theta. Now look at the C part. It is 1 minus sin square, we just use this. So I'm directly replacing it with cos square theta. 1 minus sin square is cos square. So sine of 2 theta divided by square root cos square 2 theta. Yes. That's nothing. Sin square theta plus cos square theta is 1. This is the first identity you have to memorize. First, this encircled in black, and second is tan theta is equals to sin theta over cos theta. These two identities you have to memorize. However they equal, this is the proof. Proof is not something which would be asked in exam. So just these two, 1 and 2, you have to memorize them. Then we use them interchangeably. So the first question was that sin square 3 theta plus cos square 3 theta. This was the question and the answer is straight 1, nothing else. If the question would have been sin square 7 theta plus cos square 7 theta, angle must be same and both of them must be squared. The answer is straight away 1. Sin square y plus cos square y, then it is something else. Then we'll have a statement in the question what the examiner expects us to do. For example, you have cos square x plus sin square y. Now this is something else. This is not our identity. Okay. Now this is something else, and this question statement will tell us what we need to do. And the second question, third part was sine of 2 theta divided by square root of 1 minus sine square 2 theta. At this stage, I'm not expecting that you've memorized it, so let me write it. This was sine square theta plus cos square theta is equal to 1, general form. First identity. Second was tan theta is equals to sine theta over cos theta. Two identities for now. So this 1 minus sine square gives me the hint that I should use the first one and make cos square the subject. So if it is sine square theta plus cos square theta is equals to 1, I'm making cos square theta the subject. So cos square theta equals 1 minus sine square theta. Now if I use this, I can replace 1 minus sine square 2 theta. Makes no difference if you have 2 theta, the angle must be same and both of them must be squared. So if it is cos of 2 theta and 2 theta, we can just replace them. Numerator stays same, sine of 2 theta divided by 1 minus sine square 2 theta is being replaced with the last part, that is cos square 2 theta and square root. Now simple mathematics, square root cancels out with square, we are left with sine of 2 theta divided by cos of 2 theta. Here comes in the second identity. Tan theta is equals to sine theta over cos theta, or you can say sine of x over cos of x is equals to tan of x, or we can say sine of 3 alpha divided by cos of 3 alpha is equals to tan of 3 alpha. So whatever it is, when sine and cos are divided and the angles are same, we get tan. So in this case, our case, sine and cos are divided and angle is same, so we write tan of 2 theta. So we can say that when you write this or this, it means the same thing. If you have the value of theta, suppose let's say theta is equals to 1.2. So if you put 1.2 in the first line or the last line, the answer would be same. These are known as trigonometric identities. Look at this worked example. This is cos 4 theta minus sine 4 theta. Now this is nothing close to cos square theta and sine square theta. So we must do something to convert it into the form of identities we know. So if you remember, x square minus y square was supposed to be x plus y into x minus y, one of the identities. Do you remember this? So I'm using the same concept to convert them into a plus b and a minus b. So see, if you consider that this is cos square theta whole squared minus sine square theta whole squared, mathematically are the numerators still same? Now having said that, left hand side is equal to right hand side. We're using left hand side and we'll simplify it to this. Is this step clear? Circled in red. So when we make these squares, this is now x square minus y square, and that is x plus y into x minus y. So till this step we used simple algebraic form, and we did write cos square theta plus sine square theta into cos square theta minus sine square theta, and the denominator is already in simple form, so it comes with us. And then you see that sine square theta and cos square theta was supposed to be equal to 1, right? So this disappears because it is actually 1. Now numerator and denominator, left with numerator and denominator, what should we do? One choice is to split them, cos square over cos square minus sine square over cos square. Why so? Because if you've memorized it, the two identities, you would know that sine over cos should give you tan. So cos by cos should give you 1. That is one benefit. If you've memorized it, you can foresee what your next step would be. So when you split them, cos by cos is 1 and sine by cos is tan, and prove that left hand side is equal to right hand side. Are you getting it? Now this is something which will require a lot of practice. This is not the reading part, this is not the listening part. You would have to write them, and you can always foresee what the next step would be. Yes. This would be very scoring because it is limited. Identities are limited. Once you memorize them, you'll get used to them. And there are these cute little parts as well. Small and scoring. For example, given that cos theta is negative 3 by 5. So I'm just drawing a triangle to understand that if this is theta, cos theta means base over hypotenuse. Using this 3 and 5 in Pythagoras theorem, I'm getting the other value as 4. Do we agree? First thing. Second thing, it says cos theta is negative, and hint is given that theta is reflex. Reflex means it is more than 180. I am very sure it lies in third, not in fourth. Can you have an argument on this? Why third, why not fourth? Reflex would mean more than 180 and less than 360, right? Yes, that's right. That's the answer. That's the correct answer. So cos is negative. Being reflex, add sugar to coffee. Being reflex and negative, it must be in the third quadrant. So this is where we are. So it says find the value of sine theta. I'm looking at my triangle, and from there I can say sine theta is equals to perpendicular over hypotenuse, that is 4 by 5. But we know it lies in the third quadrant and their sine is actually negative. So this is our answer. Sine theta is negative 4 by 5. One more question. Third quadrant, add sugar to coffee. Third quadrant is positive or negative for sine. So that's how I got it. We'll do one more question. 4 over 5 from my first triangle. These three things were known. 5 was known, 3 was known, theta was known. And then I got 4. That's the basic angle. Basic angle is always acute. To adjust the reflex thing, we are adjusting it with positive and negative sign. Whatever the angle is, the basic angle is always same. Let me try one more. You'll get a clarity. B part. Sine alpha is 2 by 5. So whatever it is, I haven't read, is it obtuse, acute, reflex, anything it is. So if this is alpha, sine alpha is perpendicular or hypotenuse, so this must be 2 and this must be 5, right? To get the third side, hypotenuse square is equal to base square plus unknown squared. So 25 minus 4 is equals to x square. This is 21 is equals to x square, and x is equals to square root 21. So do we agree the third side is square root 21? So this is my basic triangle. I'll be using it at all times. And then it says alpha is obtuse. Obtuse means more than 90, less than 180. So this is where it lies. And what are we supposed to answer? That is cos of alpha. So cos of alpha, now I am looking at my triangle. At my triangle I can see that cos alpha is square root 21 divided by 5. But to decide is it positive or negative, I come back to this diagram and tell that cos should be, what should be? Cos positive or negative? Anyone? Add sugar to coffee. Cos is supposed to be positive or negative if alpha is obtuse? Negative. So this is the answer to this question. Okay, now this is, you will come, this is simple algebra. You've given with P, you're given with Q, show that this equal this. So it is nothing, just substitute the values. So P is 3 cos theta, we just substitute it in this, and Q is 2 sin theta, we just substitute it. Let me write it here to have more writing space. P is given, that is 3 cos theta. Q is given, which is 2 sin theta, and what we need to prove is 4p square plus 9q square is equals to 36. So let's see, 4p square plus 9q square, that was 9, was that 9? Yes, that was 9. Now this is the question, and we just plug in the values. So 4, value of P is 3 cos theta whole squared plus 9, value of Q is 2 sin theta whole squared. 4, now 3 squared is 9 and cos square is cos square. 9 stays outside, 2 square is 4 sin square theta. Simple algebra. 9 4 times is 36 cos square theta. 9 4 times again is 36 sin square theta. Now you take out 36 as common, 36, and we are left with cos square theta plus sin square theta. And what was our first identity? Sin square theta plus cos square theta is equals to 1. So just replace it with 1 and shown. Is this thing clear? We'll stop it here for today. I can do it today, like we won't go to the next concept, but we do have time. Okay. The important take-home notes for today are: memorize the two identities. Sin square theta plus cos square theta equals 1, and tan theta is equals to sin theta over cos theta. These two identities, these will be used interchangeably.